Okay, so welcome to this video this morning. I'm honoring a request that I was given a week ago to do a question on longitude and latitude. So a ship in distress relays a signal and give its position as 45 degrees south, 30 degrees west to rescue vessels at A 45 degrees south, 35 degrees west and B 52 degrees south, 30 degrees west respectively, picked the signal and started moving immediately towards the scene. If A steams due east at 18 knots and B due north at 24 knots, calculate the time taken by each to arrive at the scene. So this kind of problem requires us first of all to have a picture so that we can visualize clearly where is this ship that is in distress and where are these other two ships that are coming to rescue the one in distress. So I'll come right here and transfer that information here. So this is my earth. Okay, that's just the sketch of the earth, and I have a town here which is 45 degrees south. So this is 45 degrees. Allow me to write it on both sides. 45 degrees south. Then I locate now the position of the ship in distress. So we have 35 degrees west. So this is my 35 degrees west here. 35 degrees west, and then this is the position, right? Then there is another ship which we are calling a rescue vessel, which is at 45 degrees south, but 45 degrees. Okay, so we have 45 degrees. This should have been 30 degrees west, and so we have the rescue one which is 45 degrees south but now 35 degrees west. So this is the position of the rescue vessel A, so call it A there. So you can see that it is only 5 degrees to the west of the ship in distress, so it captures the signal 5 degrees away from here. So this is the position of A. Allow me to write this one as ship in distress, so just write it SD. So we also have another rescue vessel, that is B, located at 52 degrees south, probably somewhere here, and on the same longitude as the ship in distress, so this position here. So you notice that now it will have to traverse due north to rescue it, and this one will have to traverse due east to rescue this ship. So we have two distances here, so the distance along the great circle and the distance along the parallel of latitude. So that's the geometric intuition that we are made to have when we extract that information from that question. So that being said and done, so we will need to write that information right here so that we can get started. So we know A is 45 degrees south and 35 degrees west. The ship that is in distress is 45 degrees south, same latitude as A, but 30 degrees west. The other ship, which is south of the ship in distress, is 52 degrees south and 30 degrees west. Now we are going to compute the distance now from here to here and the distance from here to here, then we compare the times. Okay, so what is the distance A to SD? So this is the distance along the parallel of latitude, that's a small circle, and because we are given the speed in knots, we are going to use distance in nautical miles. For a small circle, distance in nautical mile is given by 60 theta cosine of alpha, where this alpha is the latitude and this theta is the longitudinal difference. So in this case, we are going to take 60 times the difference between this and this, which is 5 degrees, times cosine of 45 degrees quickly. So if you multiply this, you get 300 times cosine of 45, you get 212.13 nautical miles. Then we also take the other distance here, B, to where the ship in distress is. This is along the great circle because we are traversing on the longitude. So again, distance, this is for small circle. So for the great circle, we have 60 theta. So we take 60 times the latitudinal difference. So the latitude difference is 52 minus 45. You get a 7. So 7 here. So you get 420. So we don't need a calculator to solve that. So this is 420 nautical miles. Now when we have the distances, that is 212.13 and 420 respectively, we can now compute the time. So we know time is distance over speed. So the speed of A, we are told that was moving at 18 knots and the other one 24 knots. So very quickly, so we take 212.13 divide by 18. That gives me I'm running short of space, but I'll try 212.13 divided by 18. I get 11.785 hours. Then this other one here is distance over speed. So we have 420 divided by 24. So this is nautical miles, this is knots. So when you divide, you get this distance is 420 divided by 24, you get time. And so this is 420, you divide by 24, you get 17.5. Seems like vessel B arrived much later after A had arrived, because there is a difference in time. This one was 11.785 hours and this one 17.5. So the rescue team, the rescue ship A steamed towards the ship in distress after 11.785 hours, and B steamed towards north where the ship in disdain was 17.5 hours. So we can write the first answer as 11 hours, and so we convert those into minutes. We have 11 hours 47 minutes. Then this is for the A part. Then B was 17 hours 30 minutes, right? 17 hours 30 minutes. So A took 11 hours 47 minutes to arrive at this position here, and B took 17 hours 30 minutes. So this one moved towards east and it only took 11 hours 47 minutes, and this one here, which is B, took 17 hours 30 minutes to arrive here to rescue this ship which was in distress. So I think we have been able to answer that question, because we were told to calculate the time taken by each to arrive at the scene, and that's how that question is done. Thank you.